My name is Gus Cornell. That's my email address. Today, we will be talking about securing multi TGW environments. I want to talk about lessons, tips, best practices, things learned while deploying multiple transit gateways in AWS. I'm going to spend maybe just 1 minute at the beginning talking about myself, my philosophy, where I came from. Then we're going to be talking about right into the multi-transit gateway designs, why do it, when not to do it, what are the problems that show up when you try to secure them, and what are the solutions that we found when working on these environments. A real quick personal history. I've been doing networks for quite a while. I was the first internet administrator for the U.S. Department of Transportation. I registered the DOT.gov. At the time, I was very happy that I bid Department of the Treasury, which had to go with a much crappier 3S.gov. Today, they're called Transportation.gov and Treasury.gov, but for a while, I consider that a coup for the time. When I registered the Department of Transportation, they gave me 5 Class B public IP addresses. I asked for them, and they just gave them to me. It's amazing what they could happen at that time. I was their first firewall administrator. At that time, it was FAA, National Highway, Traffic Safety, Federal Railroad, Coast Guard was also part of transportation. About 135,000 people connected to the internet through our Network Operations Center. And I was the first administrator, which teaches me to handle quite a bit of pressure. Favorite call was, I'm calling because the internet is down. I would, of course, ask, well, how do you know the internet is down? The replies would often be something like, well, I can't print. I would say, well, can the person next to you print? Yeah, oh, okay, well, then the internet perhaps is not down. But if it was down, it was 130-some thousand people that couldn't get access. I was their first webmaster, and at that time, I learned to love modularity, the ability to swap components. If I lost a couple of floors, instead of trying to connect to a router and connect my laptop and try to troubleshoot it, I would just replace a line card. We'll take out the faulty one, put a brand new line card in, everything was up and running. So in 2017, when I saw somebody run a Terraform script and deploy about 25 different VMs, servers, gateways, do a demo and delete it all, I was hooked. And I've been involved in the cloud ever since. I've been with Checkpoint about 20 years, and I have been a cloud architect since 2017. My personal ideas about security. My grandma loved political strongmen. She was like the little old ladies that loved Mussolini. There was a military dictator in my home country, Venezuela. This was many, many years ago. My grandma loved him. The trains ran on time, she said. So yes, my grandma was a bit of a fascist, but even though I hate the idea of a police state and I hate strongmen in governments, I love the idea of a police state for securing cloud. And that's my personal philosophy. I love the idea of stop and ask for papers. And of course, in cloud, that would be segmenting and putting access controls in lines, asking every single packet, who are you, where are you going? Strip searches is really the only way to go. Deep packet inspection, looking at the malware payloads, looking for data that's been exfiltrated. Encrypt everything, secure your own communications, and monitor everything else. Inspect TLS, SSH, pretty much every single piece of data that is not secure administrative data should be inspected. Control the infrastructure. No one builds anything without the approval, and that means usually policies that control what gets deployed in the cloud. Ask for additional info. Do not settle for what the regular information gives you. That means building custom queries to find things in the cloud that are of value. Keeping an eye over your assets, of course, visibility, lay down the law and do automated enforcement. You want something looking at the cloud 24/7, making sure that it is the way that it's supposed to be. Oversee the enforcers, of course, watching the watchmen, always fix everything that needs to be fixed the moment that it is discovered. I love auto remediation. Use every possible way to spy into the cloud. That means querying via APIs, putting agents, doing agentless scanning, pretty much every single way, log analysis. Every single way that we can retrieve information from the cloud, I love. I love to get notified and alerted every way that I can. Security inspect all new technologies. If there's a parade, lead the parade. If you are at the forefront of whatever is coming down the pike, you get to make the rules of how that usually gets implemented in the cloud or anywhere in your network. Go inside of everyone's house, no need for warrants. That means scan the host, scan the containers, look at everything inside of your network, not just the network traffic. Record and analyze every conversation, find out who's talking to whom, flow log analysis, of course, record and analyze every activity, find out who's doing what and why. That would be activity log analysis, looking at things like CloudTrail, usually automatically, and having events generated because of that. Censorship. No one writes a single piece of code that is not read by the censorship board. By that, I mean source code review. I'm a huge fan of shift left. And finally, implement risk analysis, correlate everything that you learn, and start by dealing with the most dangerous situation first. That is my police state view of securing cloud, and I use it every time that I can. And now that you know a little bit of how my mind works, let's get into why we're here. Multi-transit gateway architectures. I'm pretty sure that everyone here has deployed in AWS. That is why you register for this. And the most common way to connect multiple VPCs, multiple networks in AWS is by using the transit gateway. In each region, most people build a single transit gateway. They connect all their VPCs. And in most cases, everybody's happy. So why would we ever need to design a multiple transit gateway environment? Well, of course, the first thing that pops up is you will have more than one region. Transit gateways are regional constructs. So you'll probably have a transit gateway in the east, a transit gateway in the west. Sooner or later, you're going to realize I need to share data between my regions. I need to maybe be able to reach data that happens to be only in one region. I may need to replicate data from one region to another. And pretty soon we're linking them together. So now we have a multi-transit gateway system, the most basic one of them all. But the need is there and it comes very fast. Sometimes we need to segment inside of the region. We can very quickly find out that we may want to have an on-production and a production transit gateway. It is a very easy way to connect the environments together and keep them siloed or isolated. If we have an on-production and a production transit gateways in one region, we probably will have an on-production and a production transit gateway in the other region. Transit gateways can be meshed. We probably will want to start meshing all of them together. So pretty soon, we're going to have a pretty big system. If you talk to AWS, when you get to this point, AWS is going to recommend another transit gateway. It's going to say, if you have more than one transit gateway in the region, build a transit gateway hub. Now, at first, it didn't make a lot of sense to me. Why are we building another transit gateway just to serve as a hub? That is because you will want to interconnect the transit gateways. And the more regions you have, it makes a lot of sense to just interconnect the hubs. And I'm going to show you what I mean. This is an 8-region mesh. This is a single transit gateway per region. So if I had 2 or 3 transit gateways to be a part of this mesh, I would have a gigantic mess. So transit gateways can be meshed, but as your regions go up, you can get into a more and more complex environment. At this time, the question that you probably will be asking is, should I do Cloud WAN instead of transit gateways? Very quickly, this is not about Cloud WAN, so I'm just going to basically touch very quickly on what it does. It lets you build a global superhighway. You can segment that superhighway in any way that you want. So you can have a segment for dev and non-prod, one for production, maybe one for hybrid connections that have cloud resources and resources that are outside of the cloud. So your VPNs, your headquarters, your direct connects going to that layer. And you can have a security segment as well. Cloud WAN allows you to route and instruct policies of how to go from one segment to another. And you can connect VPCs directly into Cloud WAN. Now, Cloud WAN is very, very powerful. I think it's extremely useful for things like Ingress and Egress. It is not fully mature, in my opinion, for East-West. And in many cases, your network may not need it. So the question is, when should we use TGWs? When should we use Cloud WANs? If your network is going to be mainly a regional system with a few regions, 3-4 regions, even if those regions are spread worldwide, and you want to manage your own peerings and routing configurations, you want to be granular about it, you want to use your own automation, then transit gateways is really all that you need. Cloud WAN is really for major global networks when you have more than 4 regions, I would say, globally. That's what I would begin thinking about it. The nice thing is that the world is better together. Transit gateways and the Cloud WAN from AWS are not exclusive of one another. You can use them together. You can start with TGWs, and at some point, when you're hitting 4, 5, 6 regions, you can start building your Cloud WAN a global network on the back end and start connecting your TGWs to it. So it is something that you can grow into. And today we're going to be talking about TGWs. So Cloud WAN may be better if your regions look like this, but in most cases, hopefully they won't. So the most common reason for me getting into multiple transit gateway designs is because I was dealing with companies that had multiple subsidiaries. The subsidiaries were all part of the same global enterprise, but they were silos into themselves. They were separate business units. They all had presence in the cloud, usually AWS. And in many cases, each one of the subsidiaries went into the cloud independently of the others. So the enterprises found themselves in a position to try to join everything together, right? So they may have not only non-prod and prod transit gateways, they would also have subsidiaries with their own transit gateways that needed to connect. They could decide to connect them directly into their own meshes, or they could decide to have some other transit gateway in the middle to create some sort of separation that could also perhaps accept VPNs. In addition to subsidiaries, maybe you need to connect to partners. There are partners in AWS, partners that you would love to connect perhaps at high speed without having to have MPLS connections or VPN connections. You could peer transit gateways and get the full 50 gig of connectivity with partners and other enterprises in the cloud that you do business with that also have a presence in AWS. But of course, you are not going to peer transit gateway to transit gateway without security. So the need to join subsidiaries, the need to join to partners, the need to join multiple silos inside of the enterprise itself gave rise to the need to have multiple transit gateways interconnected. Now, when we try to interconnect them at first, the first thing is like, well, do we need to put something in there? There's a lot of native security that is built into AWS. But the nice thing is that if we are connecting to something outside of our core business, whether it's a subsidiary, whether it's a partner, you really need to cover as many vectors of attack as possible. And a third-party NVA like CloudGuard, of course, adds a lot more protection for these type of security. Since we can do full payload analysis, we can do full DNS attack prevention, block things like phishing. We have change approval built into the system. We can use custom tags to allow people to group logically what can be connected or not connected between environments. We support stateful failover of legacy applications that may be moving into the cloud. There's all these little things that we usually support above and beyond the managed native gateway in AWS. That makes it sort of like a no-brainer to put us precisely to divide and protect the connectivity between our main silos and subsidiaries and partners. So when we try to insert ourselves for the first time, we have a basic blueprint. We basically like to make usually a gateway load balance, auto-scaling group of security gateways, the security hub that connects everything together. So we could pretty much say, okay, let's connect our DMC transit gateway to that. Let's connect our subsidiary transit gateways to that, maybe our production, maybe our non-production, and still have that security VPC with an auto-scaling system be the police that keeps all these transit gateway environments separated from each other. But that's when the problem started to come out. And the name of the problem is what appliance mode was built to fix in the first place. Whenever you're going from one host to another, or from one VPC to another, or one environment to another in AWS, those hosts, those environments may be in different availability zones. When you send something through a security gateway, both the request and the reply have to move through the same firewall. The firewall needs to be able to see both sides of the connection. So AWS built something called appliance mode that computes a hash. And if something is moving from one availability zone to another, the hash says this particular firewall, this particular security gateway is the one that's going to have the security for this. And that works great when you have a single transit gateway. The problem we found out is when you have multiple transit gateways and they're paired, the application, the appliance mode information, the hash disappears. So the request may basically exit your network. It may go to the top firewall, but the reply is going to come back and there's no hash. The hash gets lost between the transit gateways. So this transit gateway has no idea that this instance coming back is the same as the request that went out. And about 80% of the time gets sent to the wrong security gateway. Really, having just 20% success rate in connectivity when you're in the cloud is not what we want. So we need some sort of a way to make our connections and our inspection to be appliance mode proof. Make sure that it doesn't matter where our availability zones for the source and availability zone for the destinations are, what transit gateway they're connected to. They need to be able to go through the same security system for analysis. Now, there's a solution that came immediately to mind. We have HA cluster mode that is available in AWS. That means that we have an active standby deployment. When you have an active standby deployment, you don't need to calculate which gateway, which firewall is the one that is looking at the packets. It is always going to be the same one, the active one. The cluster is also fully stateful aware, so it will fail transparently to users and traffic that is going through. So it doesn't really matter how many transit gateways you're going across. It doesn't matter where your source and destination availability zones are, since the inspection is happening on the same gateway all the time. And when that gateway fails over on the same backup gateway all the time, the connectivity works 100% of the time. But of course, this introduces another problem. What happens when you go beyond 10 gigabits? When you have to put everything through a single gateway, you're limited by what that single gateway can do. You cannot auto-scale because auto-scaling adds the multiple gateways again. So we need to keep track of the gateways. We need to have appliance mode. So we need something that allows us to scale beyond 10 gigabits, but still allows us to do the cluster mode whenever we're going through multiple transit gateways. And the obvious solution that we came up with is basically having a regular auto-scaling system for the traffic that has appliance mode that works okay, and send the traffic through the cluster when we're going through multiple transit gateways. And this works really, really well. We find out that most of the traffic that is going or flowing through a transit gateway is traffic that belongs to the actual silo. It belongs to subsidiary A or subsidiary B, or is part of the non-production traffic, or is part of the production traffic. It could also be traffic that's destined for the internet. The internet has no problems with availability zones. There's just a single availability zone out on the internet. So we can use a gateway load balancer, multiple gateway auto-scaling system. So all the traffic that's going to stay within the silo, all the traffic that is going out to the internet can be routed through that auto-scaling group. And if the traffic is destined to a destination that will take you through multiple transit gateways, we can send that traffic through the cluster system. The cluster system becomes just one more pair of gateways that could be added to the total of the scale system. So if our scaling auto-scaling system usually has 2 gateways, our system would have 4. If this goes up to 4, our system would have 6. So we are basically solving the problem by adding 2 additional gateways in HA mode and routing the traffic so we have full connectivity regardless of how many transit gateways we have. Since most of the transit gateway to transit gateway design usually stays around 10 gigs, it's not the main traffic that's flowing through multiple transit gateways. It's just traffic that needs to go from one region to another, or one silo to another, or one partner to another. So usually the combined amount of traffic is something that we can handle with a 10 gig connectivity, which is what a single gateway can handle in AWS. Using this model, we can get into very complex designs. We can have core transit gateways, we can have non-prod, we can have prod, we can have partner gateways, and everything in any specific region can be handled by the combination of the auto-scaling group plus the HA cluster. The routings can be set up on all the transit gateways that are involved, so they know that they can send the traffic out of one direction or another direction, depending on where they go. But another issue is readily apparent when you see a diagram like this, and that is there's a lot of routing information here. This routing information can be very complicated or can be very simple, depending on how we assigned IP addressing in the cloud. If this is something that you are designing right now, if you're thinking of, it is the perfect time to build quadrants and silos with specific IP ranges. Hopefully, IP ranges that can be supernetted or combined. So that way, instead of having a list of 10 or 20 different CIDR blocks in a particular region, you can have a single supernet that defines that region. You can have a single supernet that defines your non-production systems, your production systems, your subsidiary A, subsidiary Bs. Partners may be a little trickier. Partners may have overlapping IP addresses and so forth and so on, which can be handled by a checkpoint system. But if you're going to be controlling the routing addresses inside of your environment, and if that enterprise address can be siloed, can be simplified by having groups of addresses that can be supernetted, that can be combined, then even if you're doing static routing, you have the capability of having something manageable. We are still dealing with the problem of maybe we really want to do VGP when our network gets to be this complex. Sadly, AWS doesn't have any easy way to inject BGP other than directly from each specific path. What we would love to have is some sort of BGP route map transmission that we can inject into the AWS fabric that pretty much contains all the information of where to go and what the next hop is anywhere you want to go to. We can only do that today either via VPN or GRE tunnel connections, and usually only when that particular hop happens to be the path that leads to those networks. So on most of our enterprises, we're still using static supernetting, but we are working on that BGP issue, and hopefully we'll have a fix real soon. Now, the basic routing may seem complicated, but it really isn't. I'm going to go real quick to how the routing works when you're moving from one region to another and you're going through TGWs that are appearing together. I'm going to start on the right-hand side at spoke non-production spoke number 3. There are hosts in here. Those hosts are in a subnet. The subnet pretty much say no matter where you're going outside of this VPC, go to the TGW, whatever TGW they happen to be connected to. That traffic is going to hit the attachment. Everything you see here in purple, these are attachment route tables. The attachment route tables work when the packets are heading towards the TGW. So this routing table will not be read if the packet is coming from the TGW towards the spoke, but it is read when the packet is leaving the spoke towards the TGW. We have a couple of routes here. We could have more, but for this example, we have 2. We have one that says default route to the internet sent to the gateway load balancer VPC. That is the one where we have our auto-scaling set of protection gateways there. The traffic then gets routed over here and out into the internet it goes. For the way back, we see that the source is our 10.0.0.16, and we have a packet that's going towards the transit gateway. It's reading this particular route table that says go to the non-production spoke number 3, and that's where the packet is heading. If the packet is going to this side, if the packet is going to the 10.128 range, it's going to leave the VPC because we have a default route that says so. It's going to hit the transit gateway, and the transit gateway is going to have a route that sends it to our east cluster. So the packet is going to come in, it's going to go into the east cluster. There's a subnet here on the attachment that says everything is going to go to the active system. The active gateway is going to process that. It's going to be sent right back to the TGW because that's what this subnet says. And again, we have a packet heading towards the transit gateway. It's reading this routing table for this attachment, and it says if it's going to 10.128, which it is, send it to my peer with the west side TGW. So it's going to go into the peering link. And something very curious happens when you peer transit gateways together. You can attach routing tables to each side of the peer. The peer happens in both directions. There's a peer in this direction, there's a peer in this direction, and each one of those can have its own transit gateway. For the peering in this direction, we're going to read that when the packet goes towards this transit gateway, and it says if it's destined for 10.128.00, which it is, go to the cluster on the west side. So we're going to go here and get inspected by this cluster, and then we're going to go back into the transit gateway. And if we're going to 10.128.00, we want to go to spoke number 2, which is where our destination is. The question that gets asked by most everybody at this point is, do we really have to inspect on both regions? It actually makes routing a lot easier if we do. We don't have to, and we'll see some ways to exclude traffic from doing that. But if this is one subsidiary and this is another subsidiary, you probably want to have each subsidiary have control of what goes out and in of their particular transit gateway system. So you really want packets that are leaving and packets that are entering your siloed transit gateway to have an inspection that you control. You may not always control both sides of this equation. How do we bypass these? We may have some massive amounts of data that are moving from one transit gateway to another. In most cases, that is not the case. In most cases, there are enterprise applications that live in one subsidiary that are open to the entire enterprise. Sometimes there may be VDI connections, RDP connections, SSH connections. These are connections that will flow perfectly fine through an inspection or a double inspection. But we may have terabytes of data that are moving from one region to another, from one silo to another, because there are databases that need to be replicated. There's data that got uploaded in one region that needs to be replicated to other regions. We can specify that data, that source and destination, and bypass the inspection points for just that data. We can have dedicated routes in our attachments that can be very specific. They can be to a specific VPC. They can be to a specific host inside of that VPC. So you can say, inspect everything except the traffic that's going to this /32, because this /32 is my backup server, my shared enterprise backup server, or is a huge database server that's that I'm uploading, you know, thousands of hours of video, or however many terabytes needs to be loaded. And our architecture allows us to do a bypassing for those systems that need to be excluded. Maybe it's a financial system. It can handle no latency whatsoever. So we need to minimize the latency and make it direct. We can then put an entry here. We can make, again, a /32, a /16 for the entire spoke. And when we go into the attachment, there is a route there that says, not go here, like it may say in another route. It would say go directly to the peering. It would go into the peering. It would read the inbound on this side and says, you know, if you're going someplace else, go to the cluster. If you're going to this specific host or this specific spoke, go directly to it, and boom. We have this transmission between VPC to VPC across the multiple TGWs. That traffic is not getting inspected at all. So you do not want this. If these are partner connections, if these are usually subsidiary connections, but if this is inside of the main network, and these are maybe non-production to non-production, production to production, and you say, okay, this is backup data, or this is a database that has already been inspected, and I'm just replicating it, I can safely bypass my inspection and send it directly by just adding a bypass route on my transit gateways. Okay, so what other multi TGW architectures can we run into? We already talked about subsidiaries. We talked about connecting to partners. We talked about how we can have an expandable a security system that can be attached to those transit gateways and allow us to filter everything that is going out, everything that is coming in. What else may this be used for? You may need to secure environments that look a little bit different. The most popular one of these is VMware environments in AWS. That is when the multi TGW architecture reared its head again. When you connect to a VMware environment in AWS, the most common way to connect, when you look at the instructions from VMware, when you talk to an AWS engineer, when you talk to the VMware people in headquarters, is just do a direct connect drop directly into that VMware environment. Now, that is great for extending the VMware data center from headquarters into the cloud. But sometimes the systems that are here need to be reached by the rest of your AWS infrastructure. The systems that are here may need to go out to the internet. And since they're already in AWS, they may want to go out to the internet via AWS instead of having to come all the way down to on-prem to use an on-prem gateway. So the question posed to us was, how do we connect this VMware environment to the rest of AWS so we can send traffic out into the internet, so we can have people in AWS connect to this environment directly? And it's pretty simple. VMware just says you can attach our SDDC infrastructure directly to a VPC. You can attach it directly to a transit gateway. But the preferred way to attach VMware is by having a virtual TGW on the VMware environment. And here we have two TGWs again. This TGW does not have any appliance mode information associated with it. It doesn't understand multiple availability zones on the AWS side. So we're in the same conundrum as we were before. But luckily, even though appliance mode would fail here because it's sending maybe to one gateway and the reply comes to a different one, the same solution that we have on regular multi TGW architectures will work when the TGW is inside of a VMware environment. So we can attach that SDDC environment to both our clusters and our ASG system. And once we have that, we can start sending traffic through it. If the traffic is going from VMware out to the internet, it would go through our auto-scaling system. If it's going through one of the other AWS sites, whether it goes through a single transit gateway or more than one, it is going through the HA system with a single inspection gateway, and the traffic does not get dropped in either direction. If we have maybe VDI systems that need to connect to here, or applications here that need to connect to systems here, everything can be inspected at this point, and we can have two-way communications, including going out to the internet. At this stage, I got a request. This system interconnection lets you inspect traffic that is moving to and from on-prem. That is not sometimes it's not something that is desired. So even though this design can be plugged transparently into a major system, there might still be the need to connect this directly to the main direct connect, and it actually works both ways. You can have that virtual transit gateway attached to both direct connect and have a direct pipe to headquarters, and at the same time, you can have it attached to additional VPCs inside of the cloud. So you can direct traffic that goes to on-prem directly down the direct connect without having any inspection in the cloud. Traffic that's going to the internet, going through our auto-scaling system and going out this way. Traffic that's going to the rest of AWS or any subsidiary or partners that are part of our grand connectivity scheme, it can head over in this direction as well. This is an alternate method of integrating VMware environments, and the exact same solution that we use for regular TGWs will work with the virtual TGWs that we find in VMware. What else will lend itself to multiple transit gateways? Well, I found this again when securing an SD-WAN connection. When connecting an SD-WAN network into AWS, the most popular way of doing it is by connecting the SD-WAN systems via GRE tunnel to a transit gateway. This is more popular than connecting it using VPNs, because the GRE connection can go up to 5 gigs versus a single gig connection that you have when you're using IPsec. So connecting SD-WAN spokes to transit gateways became a very popular way of connecting SD-WANs to our major environment. The problem in here came when we wanted to secure this traffic. If we have a security system in here, and we want to have our traffic that is going or coming from the SD-WAN or going out into the SD-WAN inspected, we want to have some sort of a boundary that controls what goes out or what comes in from that SD-WAN. We found out an issue, and that is while we can normally send traffic to inspection directly from a TGW attachment, there is no way to add a static route here that overrides the BGP exchange between the transit gateway and the SD-WAN system. So traffic coming from the SD-WAN that's hitting the TGW would not want to be redirected to an inspection point, because the attachment could not have a static route that says, if it's going towards the TGW, send this way. However, one of the things that multiple TGWs give you is they separate or break your routing architecture. They allow the BGP information that's flowing through one TGW not be automatically replicated to every peer TGW that you have. This is actually a drawback in some situations, which is one of the reasons to use the Cloud WAN, which allows you to use BGP everywhere. But in this particular case, it's a plus, because if we add a TGW specifically for the SD-WAN connectivity, we have a peering. When we have a peering, if you remember, we can set specific static routes in the peering to say what the traffic that's moving or flowing between TGWs does. And we can now redirect that traffic through our inspection point, and from there to the rest of our infrastructure. If it's leaving our infrastructure, we can again send it to that inspection point and then send it to the TGW that controls the SD-WAN. So this way, because we can use the TGWs to break or put some sort of a wall on that dynamic BGP exchange, we can control the traffic when it needs to be controlled between moving from one environment to the other. Okay, that is the main trust. We're at 45 minutes. We are going to do some Q&A next, I believe, but I just wanted to show once more my email address. My name is Gus Coronel. gcoronel@checkpoint.com is my email. If you need to reach out to me because you have questions about integrating multiple TGW designs, you can actually reach any one of the cloud architects that work for Checkpoint. You may want to reach me because I'm giving you my email address directly. Feel free to send questions directly to me at any time, which perhaps may not get answered today in this particular seminar. And I will look at your problem. If you're showing me a problem that I have not seen, that is the best thing you can do for me. Boredom is the death of a cloud architect. And with that, I'm going to go ahead and stop sharing and open up the QA side of this.
So, Gustavo, thank you very much.
Sure.
Roman answered most of the questions on the Q&A. One thing that I think that need to be mentioned regarding Cloud WAN. So what is the advantages of Cloud WAN and maybe the disadvantage over TGW interregion? So give me a moment to share a presentation that has been shared with us. I will also going to upload the recording and the presentation that we are using here on the session, but give me a moment to share my screen and show you something. So I believe that the questions that we are going to get is how we can eliminate the need for the cluster, for the AZ cluster. So there is an option to eliminate the need for the AZ cluster and just use the scale set solution with the Cloud WAN. And the way it's going to work is that each packet is going to inspect twice. So if, for example, we send the traffic from this VPC prod in region 1 to VPC prod on region 2, the traffic is going to be inspected here on the in-out inspection CloudGuard skill set solution over here on region 1, and is also going to be inspected over here. So this is the disadvantage of using the cloud one, but if you're going to use this solution, you won't need to use the cluster. So you need to take that into consideration when you're doing the design. Roman, anything else that you want to add on top of Gustavo?
No, I guess we are good. If there are any other questions, feel free to ask us.
And yeah, someone saying that the routing is a big challenge when you deploy a transit gateway architecture. That this is right, and the cloud one also is solving this issue. But this is a matter of practice, and you always can reach Gustavo or the professional services to give you a hand with this challenge. So another question, if the recording is going to be available. So yes, on Checkmate by tomorrow, you will find a post with the presentation. I'm also going to upload the AWS presentation and also this recording.
I can answer some of the questions that I've seen.
Yeah, go ahead.
That I'm seeing. Okay, so is it the best practice in common deployment to provide outbound internet access for VPCs through a central security VPC? I find out that there's not really always a best practice in cloud. There are many solutions that are equally secure. I prefer myself having a central VPC for egress because you get economies of scale. So the routing becomes easier or simpler since your default routes are pointing to one place instead of multiple places. If you have a single system to manage rather than 2 or 3 separate systems, maybe one for egress, one for ingress, one for east-west. So I kind of like the common central deployment. On the thinking of a multi-cloud scenario, would that multi TGW showed for the SD-WAN solution work as well? Yes. The only reason we're using multiple TGWs in AWS is because we may not want the SD-WAN to advertise and learn BGP directly from the rest of our network. We want to be able to control that a little bit more granularly, and that GRE connection does not allow us to do static routes. But if the question is, can we make that connection via a VPN? Yes. And with VPN, we may have a little bit more control in that matter. Let's see, with multi TGW, if we inspect traffic in both source and destination regions using a gateway behind, do we still need a cluster? We need a cluster when we're going through multiple transit gateways because it is the only way to guarantee that both the request and the reply are going to be inspected by the same gateway, which is a requirement for most security inspections. In many cases, you're just adding one pair into what is a multi-gateway system anyway, because usually your central inspection point is going to be an auto-scaling group. And most of the time, that's going to be between 2 and 4 gateways. So basically just it's like dedicating 2 of those gateways just for inter-transit gateway traffic. They just happen to be broken down into a separate cluster instead of being part of the auto-scaling group.
The question, what is the difference between static routes and propagate? So propagate automatically. So for example, if you add a subnet in an existing VPC, the subnet is going to propagate to the route table. You don't need to create a static route. So
correct. Yes. If you're using BGP or any sort of dynamic routing, and you have a very complex network, I've seen networks 4,000, 5,000 advertised routes. You really want to use static routes for exceptions. But in a multi TGW environment, you may need to be very specific as to where you want to send traffic in one direction or another. And there's no easy way to inject custom BGP routes into AWS today. So static use tends to be the most popular solution. Actually, yes, in both Cloud WAN and in the multi TGW traffic, it makes sense to inspect traffic in both regions. Again, remember, in some cases, not in every case.
With Cloud WAN, you don't have any other choice. So you have to inspect the traffic in both regions.
Yes, you can get a little more granular with TGWs, which I think was one of the reasons. If you want a little bit more control over the automation or the routing instead of the region, the TGWs make sense. Yeah.
Yes, the recording is going to be available on Checkmates. I will upload the recording by tomorrow, end of day. Yeah, give me a second. I will give you permission to talk. Yeah, go ahead. You can talk.
So my question is, like in the Cloud WAN, we don't need that cluster firewall setup, right? And we can have our, and similarly, like in the multi TGW, if let's say we have one TGW in region 1, second TGW in region 2, traffic flowing between region 1 and region 2, and if we do the inspection in both region 1 also and the 2 also, then also do we need that cluster firewall, or we are good?
If you have TGW to TGW peerings, if your traffic is going through 2 TGWs or more, the only way to do it outside of Cloud WAN is by having that cluster until AWS fixes the appliance mode issue. Once the TGWs are able to share the appliance mode information, you can simply remove the cluster and have everything go through the gateway load balancer auto-scaling group. But today, while that limitation is there, if you're going through multiple TGWs in a region or across regions, instead of using the Cloud WAN, you will need to go through the cluster.
So,
but only one cluster, right, Gustavo? You need just one cluster.
You can do just one cluster. I have done it, but it makes routing a little bit more complicated.
Because you
exactly,
because
the routing is different in the directions. Yeah. So
activate a NAT. Okay.
Well, the question is, the VPN appliance mode is for the outgoing, right? When the traffic goes out of the TGW, it keeps that session information, and that is for the exit from the TGW, right? So if once,
yes, go ahead. Sorry.
So when it's there multiple TGW, so traffic coming from TGW region 1, going to TGW region 2, and it exit in the AZ1 in region 2, right? So now that TGW region 2 knows that this traffic is going via the AZ1 in region 2. So for that particular session, that 5 tuple, right? It will keep sending the same traffic on the AZ1 in the region 2. So why do I need that another set of firewalls, cluster firewall?
Because what you just mentioned works perfectly fine when you have a single transit gateway, because AWS built a hash so that the traffic will always stay symmetrical. And if you are going or crossing from one availability zone to another, that hash will keep everything straight. The problem is that hash is not shared when you peer multiple transit gateways together. It gets lost. Yes. So that's why we need that. Yeah.
But that hash is for the traffic going out of TGW, right? This is hash. TGW calculate this hash.
The hash actually is based on source and destination, but again, it gets lost when it leaves the transit gateway.
Yeah,
and this is something you can test. Yes, you can test this. When you
Yeah,
send
that's why
traffic
I'm
through
asking.
it, yeah.
I'm running setup with multi TGW for the last 2 years, and we have at least like 7, 8 regions, and they're talking to each others. And so far, nobody have complained.
Are you natting?
No, no NAT.
You have no NAT at that? Well, then I would love to take a look at your design, because I ran into this problem quite a bit, actually. And I started getting the problem when the peering started. I'm assuming that you're peering your TGWs together, right?
Yes, yes.
Yeah.
We are pairing
Okay.
TGW together.
Yes. Appliance mode is not shared through the peers.
Yeah, I know that.
Yes. So if you're not inspecting, everything works great. But if you're inspecting and you have multiple gateways for inspection, it's going to work sometimes fine. And it will work if there's a single gateway on your autoscaling group.
Nope.
It will work if you have
gateways.
the same availability zone on both ends. But if the availability zone changes, and sometimes it does just by switching accounts, you may be going from one zone 1A to 1A, but they're not really the same. Appliance mode will be needed, and it won't be shared, and sometimes the connections will be dropped.
Yeah.
I would yes, send me an email. I would love to take a look at your design, because if you are getting 100% connectivity with inspection on multiple TGW peerings, I would love to see how that traffic flows. Yeah.
Sure. I will contact with you.
Sure.
We have a question from James. Do we need to enable appliance mode on all VPC attachment, or just on the inspection VPC attachments? So just on the inspection VPC attachments.
Yeah.
The security VPC.
I usually do it everywhere, just a standard, but yeah.
James also asking if you could explain a bit more why get TGW peering break appliance mode. So it's only break appliance mode when you connect to TGW in 2 different regions.
Yes, the peering, well, actually, in the same region as well. The peerings do not share appliance mode information.
Oh.
So 2 TGWs that are peered will not share appliance mode hashes between them. That's what we found out. If you can use NAT, and that will take care of it as well. If you use NAT, you don't have to use a cluster. You can use your autoscaling group. My experience has been that most customers will push back on a NAT. They want, if the traffic is moving internally inside of their network, they don't want traffic going from one region to another, or one zone to another, or one subsidiary to another being natted. That will fix the appliance mode issue, though, but so will the cluster.
Well, one thing to mention that VMSS does not, and VMSS with gateway load balancer does not support NAT.
Yes, when I NAT in there, I use a NAT gateway. You can use NAT gateways with private addressing. So the traffic seems to be coming from the NAT gateway itself, and that solves the issue, since the reply will come to the same NAT gateway and usually the same availability zone as it left.
So Gustavo, I think that we don't have more questions. Thank you very much for the session.
Sure.
Till the next time, Roman, also thank you very much. And I will upload the recording and all the presentation by tomorrow. Thank you very much.
Thank you very much, Gustavo.
Sure. Hey, bye-bye, everybody.
Bye-bye.